Hello my dear students. Once again welcome back to our maths lecture. We are discussing chapter number 6, that is lines and angles. In our last video lecture we have completed exercise 6.2. Now in this video lecture today we are going to discuss theorem 6.7, which is known as angle sum property of triangle. My dear students, you have used this property of triangle, angle sum property of triangle in your previous classes. Like in class 6th, 7th and 8th, you have used this angle sum property of triangle to find out the missing angle of any triangle, right? So now in 9th standard, in today's video lecture, we are going to prove that the sum of the angles of a triangle is 180 degree, right? In triangle there are three angles. Let's have a look on the board. We have triangle PQR and angle 1, angle 2 and angle 3. These are the three angles of any triangle PQR, right? So this is the data that we are given. So let us first write down the data we are given. We are given triangle PQR, right? So in triangle PQR, angle 1, angle 2 and angle 3 are the angles of triangle PQR, right? Now what we have to prove? We have to prove that the sum of these three angles is 180 degree, right? So we are going to prove that angle 1 plus angle 2 plus angle 3, this is equal to 180 degree, right? Now let us start our proof. See, to prove that the sum of these three angles is 180 degree, we have to construct one thing. Actually we have to draw a line which will be passing through this point P, right? So we are going to have a line XY. We are going to have line XY. As you can see, this is line XY which is passing through this point P, right? Now, see, after drawing this line XY which is passing through P, you can see there are two angles. Let's say this is angle number 4 and let's say this is angle number 5, right? So by drawing this line XY, we got two angles, that is angle number 4 and angle number 5. Now students, as you can see, this line XY which we have drawn is parallel to this side QR, right? It is clearly seen from the figure that this line XY is parallel to QR, right? So first of all, we have drawn line XY, so that we need to mention here that draw line XY parallel to QR passing through point P, right? We have drawn line XY which is passing through point P, right? Now according to the diagram, it is clearly seen that XY is parallel to QR, right? So we can say that here XPY, right? Line XPY, this line is XPY, is parallel to QR, is clear from the diagram, and as you can see, this side PQ and PR, these two sides behaves as a transversal, right? If you take this XPY and QR as a parallel side, and if you see this PQ behaves as a transversal, similarly this PR behaves as a transversal, right? So we can say that XPY is parallel to QR and PQ and PR are the transversals, So according to the diagram, if XY is parallel to QR and if we take PQ as a transversal, as you can see the Z-like diagram, right? I'll show you. See, you can see the Z-like diagram, and from Z we got the idea that angle 4 and angle 2, right? Again, angle 4 and angle 2, right? These two angles are equal. Why? Because they are alternate interangles. And similarly, if you take PR as a transversal, you will see that again you will get Z-like diagram. Now in this case, angle phi will be equal to angle 3 because this will be the alternate interior angles, right? So we can write two results that angle 4 is equal to angle 2, angle 4 is equal to angle 2, and similarly if we take PR as a transversal, we will get that angle phi and angle 3 will be equal. Angle phi is equal to angle 3. We need to mention the reason why these angles are equal, because these are alternate interior angles, right? These are alternate interior angles, so that's why they are equal. Now let us take this result as result number 1, right? Let us take this result as result number 1. Now students, if we add these three angles, means angle 4, angle 1 and angle phi, according to the diagram, if we add angle 4 plus angle 1 plus angle phi, these three angles will together form a line, right? This angle 4, angle 1, angle phi, these three angles together form line XPY, right? So this angle is 180 degree angle because they will together add up to form 180 degree angle. इन तीनों को ऐड कर देंगे तो वो 180 degree angle बना देंगे, right? So now angle 5 plus angle 1 plus angle 4, right? Angle 5 plus angle 1 plus angle 4, they will together form 180 degree angle. Why? Because according to linear pair axiom, right? If we add these three angles, we will get a line. That means we will get 180 degree angle. Now let us take this result as result number 2, right? So now we have two results, that is result number 1 and result number 2. Now by using result number 1, we can replace some angles in result number 2. For example, we can replace this angle number 4 by 2. Because why? Because from equation 1 it is clearly seen that angle 4 is equal to angle 2. So in equation number 2, instead of angle 4, we can replace it as angle number 2. And similarly, from angle 1 it is clear that angle 5 and angle 3 are equal. So in result number 2, we can replace this angle 5 as angle 3, right? So here we will mention that from 1 and 2, from these two results, instead of angle 5, again I repeat, instead of angle 5 we can write it as angle number 3 because angle 5 and angle 3 are equal from result number 1. So here I am going to write angle 3 instead of angle 5. So this is angle 3 plus this angle 1 as it is, angle 1 as it is, plus instead of angle 4 we can write here angle 2. Why? Because from result 1 it is clear that angle 4 and angle 2 are equal, right? So in result number 2, instead of angle 4 I am going to write angle 2 and is equal to this 180 degree as it is. Now it is clear from the statement that angle 1, I just reorder these terms, angle 1 plus angle 2 plus angle 3, right, is equal to 180 degree, and this is what we wanted to prove. Here we have proven that the sum of three angles of any triangle is always 180 degree, hence proved. Hope you are clear with this theorem. This is very easy and important theorem that we need to understand and remember, because we often use this property, right, in many calculations, right? So that's why this theorem is important. The proof of this theorem is important as per your examination point of view. Thank you.